Okay, so for this particular problem, it says for the endpoints below, find for part A PQ. Well, what that is saying is you're finding the length of PQ. Okay, that's what you're asked to find. We talked about that in the lesson. The length is the distance. Okay, that's what you're finding. And then you find the coordinate, midpoint coordinate for PQ. So first thing that you're going to do is you're going to find the distance. So square root, set it up, 11 minus 5, close square, plus -5 minus 2, close square. Just be careful, if need be, label x1, y1, x2, y2, okay? Make sure that you're pulling from the correct order pairs and putting them in the correct places. All right, so I'm going to go over to Desmos, and I'm going to put it all in because it did say to round to the nearest 10. So that's good. So I just take what I set up, and I put 11 minus 5, close square, plus open -5 minus 2, close square. All right, so round to the nearest 10th, that means I look at the second, it's a 1. So that means I'm going to leave it alone. So my distance is 9.2. And then for your midpoint, you do midpoint formula. Add bar by 2, add, and divide by 2. I've done, this will be the third. I'm not doing it again. But that's how you would set it up. Okay, it says to give the exact. All right, so what I'm going to do is I'm going to take my perfect square chart and I'm going to divide up the chart and to see, is there a perfect square that goes into 193? So 193 falls between 169 and 196. So 193 divided by 169, enter. 1, and I'm just going to keep going. Sorry, I know I put 196, but it is 193, and I know that 144 did not go, so I'm going to just keep going. 193 divided by 100. Keep going. Okay, so I have gone all through the chart. Okay, 193, 4, 9, 16. I'm just double checking, make sure that I did not leave anything out and I did type everything correctly. I'm even going to go back and I made this error right here. So I'm going to come right here and I'm going to fix it. I can do that here. Look, 3. Okay, no. 169, no. So there, I went through the entire chart, okay, and there is no perfect square that goes into 193. So guess what my answer is? My exact answer is the square root of 193. That's my exact answer, okay? Be careful. All right? Make sure, double check, make sure there was no error that you made. Okay, here you're rounding 3 decimal places. Very simply, you just put it in your calculator. All right, you count, you look at the 4th decimal place. So 1, 2, 3, 4. So that's a 9. So it makes this 4 here that I've highlighted into a 5. Okay, look at the 4th. It tells you either to round up or keep it the same. All right, distance plug it into the distance formula. So 0 minus 0 squared plus 14 minus 1 squared. It does say, it does say exact. So what I would do for the exact answer, you take what I call the meat of the problem. So what's underneath the square root, 0 minus 0 squared plus open 14 minus 1 closed squared. So it's 169. You probably say, well, Ms. Colley, couldn't you have just realized that your x's were the same? Yes, you could graph it roughly, okay, and go that route. I just wanted to show you what to do here. So I have the square root of 169. I'll recognize that as a perfect. So when I simplify, my answer is 13, okay? All right. When you have a fraction, you want to separate it into two separate problems, okay? Square root of 1 is 1. Square root of 81 is 9. This would be what you enter in the computer, okay? All right, so for this one, make sure you're set up correctly on the distance formula. I told you, you make a triangle, you write down, I like a visual, what did I do? What do I need to do, okay? This one is already done. So now I need to set up my other two to find the total length. Okay, so part A, you want to figure out which one is set up correctly. Part B, what you're going to do there for part B is you're going to figure out what's the total amount of material needed, okay? Which means I'm going to set up 2 more distance formula problems, very similar to this, okay? All right, and then I'm going to once I figure that out, I'm going to add all 3 sides together, multiply by the total cost to get my approximate cost here. Okay, again, I worked something very similar to this already, so I'm not going to do that one. All right, you have to find the length of A and B. You have to find the length of A and B, and you have to find the midpoint of A and B. I already worked that, so I'm not going to do another one. Okay, so for this one, all right, what we'll do here is you're basically, for all 4 of these problems, okay, listen carefully. For all 4, what you are doing is this is your midpoint, okay? You are working backwards, all right? You're undoing the midpoint for each of these. That is what you are doing. You are undoing the midpoint for each of these. Part B says, suppose that a given segment with midpoint H has a length of 8. How many possible non-collinear segments match this description? Well, okay, so you have you have H, all right? And then that segment is going to continue in the opposite direction, right? So this has a total of 8, right? So this is 4 and this is 4. So how many possible segments could you have to match this description? Well, to match this description, right? So I have another one. And I can keep going all the way till I get back where I started. You have it ends up making a circle, okay? It goes in a circular motion because it can't be the same line, okay? Can't be the same line. So what happens is it's an infinite amount, all right? Because it's a circle. I did leave a gap, but technically you're not even going to have a gap, all right? I left a gap to show you, all right?